Woohoo, we're back with 12.4 applications of the indefinite integral part 2. And for this one, we're introducing, the book and I are introducing a new concept called national consumption and savings, which I think is a really cool way to analyze people's behavior. This is a part of traditional economic analysis. And the important thing to remember is this is going to be a very superficial look at this concept. You can dive much deeper in this, and hopefully you will if you're taking economics classes or possibly even business classes. So we're just going to skim along the surface, which, Godzilla knows all about. So we're going to dive into it just a little bit because, again, I think it's really interesting. So first thing we're going to do is introduce two functions, and they are very unsatisfying because I'm going to say there's a consumption function, and you're going to look at that and you're going to be like, oh, economists, you already have C standing for so many other things. And the answer is yes, so why not have it stand for something else? So C is going to be some function f of y. Now, this is a new idea. Normally we have f of x. Don't trip up on it too much. There are some reasons for doing it, but you can just think C is some function, and we're going to be working with the letter y instead of the letter x. The calculations, the algebra, the calculus, all going to be the same. So y is going to be the national. So this is not like person to person. This is the whole country. We're looking at a big picture. National disposable income. And that's in billions of dollars. And now, what is disposable income? That sounds like it's money you throw away. And the answer is no, it's not money you throw away, but some people might. Disposable income, in a very superficial sense, is the money you get to choose what you do with. So that's the money you have left after you've paid for things you have to pay for. So, and that's going to vary from person to person. And again, this is a big picture. This is on a national scale. So economists figure out how much money people are actually earning and then how much they're spending on their basics, the things you need. Like you can't choose not to eat for a whole month. That's not going to work. So they try to figure out, okay, what are people spending to eat? What are people spending for their basic living needs? And then whatever's left, and again, I'm being very superficial about this, is your disposable income. It's the little bit that you might have left at the end of a month that you could choose to, to go out and go to a restaurant, for example, or buy some new clothes, maybe. Or spend some money to go see some art or go ice skating. So it's the money you get to make interesting choices about. So what we're going to look at, and again, very simplified, because I'm sure you're already thinking lots of details. Well, does this count? Does this count? And the answer is we're just going to skim along the surface and start the conversation. And I encourage you, continue the conversation with me. Continue it with a deep dive on the internet. Look it up in YouTube. Lots of cool stuff going on there. So what we're going to look at is two functions. And basically, we're going to break down people's behavior into consumption. So consuming, are we going to spend money on something, or are we going to save the money? If you have extra money at the end of the month, you could always put it in a savings account, leave it in the bank, put it under your mattress, wherever you're going to put it in that coffee can that everyone seems to have somewhere in their kitchen, in case of an emergency. So are you going to save that money, or are you going to spend that money? The saving function is S, and I just picked G of Y. I don't know if G is ever explicitly chosen as a letter. I think consumption is frequently given as F. I don't know if the saving function has a letter that usually is associated with it. So I chose G of Y. And here I'm going to write this, and everyone take a deep breath, because I know this is a lot, but can I convince you that the consumption the amount we consume, plus the amount we save is just y, whatever y is. And remember, y is, pardon me, Godzilla, y is the disposable income. And this works because of the way we defined it. We said you're only allowed to consume or save. And we could, if we were in class, I'm sure I'd have lots of questions like, what if you gave it away to someone? What if it's a gift? Well, I think that falls into consumption. And then we have to decide, we have to figure out what the person you give it to does with it, right? So this is a complicated question. You could ask me lots of details, but again, if we say there are only two categories, we're going to either throw everything into consumption or into savings, then consumption plus savings has to equal y, the total disposable income. Okay, so far so good. I know I said this was interesting, but I know it can feel a little bit, this is a little scary. Okay, but we got Godzilla here. Godzilla's right here for support. Godzilla believes in you. You can do this. So, some more words, because if there's one thing economists like more than using letters for many different things, it's words. The marginal, remember, anytime you see the word marginal, we're talking derivatives. Marginal propensity. Propensity means like tendency, whether you're likely to do one thing or another. Your marginal propensity to consume. So in other words, the derivative of how likely you are to consume is the derivative of the consumption function. And the marginal propensity to save, again, same thing but on the saving side, is the derivative of the saving function. And they are related like this. Now, a lot of times the marginal propensity to save is given as 1 minus the marginal propensity to consume. But you can also look at it as this, the two derivatives. So the slope of the consumption plus the slope of the savings equals 1. So what does that mean? Well, one number I saw thrown about is the recommendation from economists is that you save 10 or 20% of your disposable income if you can. I've actually heard 10% of your total income, but that's a lot. And right now, for a lot of people, your income is possibly not even meeting your expenses. So it's a lot to be asked for. But let's say we're living in the utopia. Everyone is paid a fair wage. Everyone has enough to eat and to live, and housing isn't super expensive. I know. You all can stop laughing now. But let's pretend utopia world. In utopia world, let's say you could look at it as 0.8 plus 0.2 equals 1, right? These 0.8 plus 0.2 equals 1. So in other words, this would be consuming about 80% of your money. So 80% of your disposable income is going to, whatever consumption you can think of. So going out to eat, or all the things I listed, going ice skating, buying art, going to see rock concerts, going, I don't even know, whatever it is you kids do for fun, buying video games, various things, spending your money on, at the farmer's market, whatever fun thing you do with the money that you have left over. Awesome. So this would be the marginal propensity to consume, which is this dCdy. And then this could be your marginal propensity to save. 0.2 would be about saving about 20%. And again, this isn't an individual measure. This is something economists are doing to look at the entire economy. So the actions of an entire country. And obviously you could also transition. You could look at the entire state or in one city or one county. So you could look at a large group of people. You're not generally looking individually here. These are bigger groups of people. So this would be such a lovely world in which we could save 20% of our of our money. So that would be cool. So that's an example of what it looks like. So what are we going to do with this? Well, you can see already we've got derivatives. And wherever we've got derivatives, we've got integrals. And again, I won't sing, but here's Elton John to remind you of the circle of math. Derivatives and integrals. It's the circle of math right there. Yep. Still not singing. Okay, so I promised you an ugly function. I mean, it's not ugly. It's just misunderstood. Here it is. Dun, dun, dun. So there's a lot to process in this problem. In the first line, there's a lot to process. If consumption is $6 billion when national disposable income Y is 0, and you're going to say to me, what? The what? How can consumption be $6 billion when there's no disposable income? It's a good question. So what are people doing? They're borrowing money. They're putting off things. You're putting off paying for some things that maybe you should be paying for so that you can afford other things. Part of consumption doesn't have to be fun. Consumption could be taking your cat to the vet, or getting a medical procedure that wasn't an emergency but has to be done. I mean, depending on the definitions of consumption, we could discuss it, but it could be things that aren't fun, things that you wouldn't choose, but you have to choose. Getting your car fixed. So is it possible that you put something on a credit card, you put something into a loan? Yes. So if consumption is $6 billion when national disposable income is 0, and the marginal propensity to consume is dCdy, so the derivative of C, consumption, with respect to Y, is this beautiful, glorious equation, find the national consumption function. So again, I'll remind you, consumption is equal to the integral of its derivative. And remember that since we're not working in X, we're working in Y, we've got to include this little guy, very cute little dy. So we're taking the integral of the marginal propensity to consume with respect to Y and getting the consumption function. So let's go ahead and take a look at that. I've got, and again, remember parentheses, 0.3 plus 0.4, and this is a beautiful symbolic way of writing this, but I'm going to go ahead and remind myself that 0.4 over radical y is really 0.4 times y to the negative 1/2. Put that little bubble in there. Remember that I'm going to write this with a numerical exponent because this symbolic, the radical, it's beautiful, but it's hard to do integration with, right? We've got to actually know the value in terms of a number. My hand loves to write the wrong number down. Thank you, hand. That was helpful. Let's try that again. Ta-da! So it's much easier to take the integral when you know what that exponent actually is, and then dy. Okay, so far so good. This is the sum of two terms, so I can integrate term by term. 0.3 becomes 0.3. Remember, we're integrating with respect to y. 0.3y. It's just like integrating with respect to x, except now we're using y's. Okay? Then we've got 0.4, and now remember what we do. We take y, and we take the exponent, and we add 1. But then we divide by that new exponent. So I'm going to write that all out, and then I'm going to deal with it in the next step. And then again, just like in the first video, since we've got a bunch of C's running around, I'm going to add K. That's what this book does. Again, your choice. You can use whatever constant of integration you'd like to use. Okay, plus 0.4, and then I've got y to the 1/2 all over 1/2. I know that dividing by 1/2 is equal to multiplying by 2 because I'm dividing by 1/2. Remember, 1 over 1/2 is equal to, can you see that? 1 divided by 1/2, which is equal to 1 times 2 over 1, which is equal to 2. So whenever you've got 1/2 in the denominator, the whole thing is actually equal to 2. Kind of, sort of. Maybe it's a little fuzzy. People are like, I don't know about that. Well, I do. That's the great thing about being the teacher. I do know. I mean, sometimes. Not always. Sometimes I have to figure it out too. Okay, so then I get 0.3y plus 0.8 y to the 1/2 plus k. Okay, so I'm not quite done because I still haven't used my, well, in the previous problem, it would have been the fixed costs, right? But this is not the fixed cost. This is when disposable income is 0, our consumption, our national consumption is still $6 billion. So let's take a look. So C of 0 is equal to, and now here's the tricky thing. Remember that all of this from the previous page, let me find the previous page. This is in billions of dollars. So we don't have to write 6,000,000,000,000,000. $6 billion is just 6, right? So C of 0 equals 6. So let's take a look at what our function's going to look like. C of 0 is 0.3 times 0 plus 0.8, 0 to the 1/2 plus k. Okay, that's equal to 0. That's going to be 0. That's going to be plus k equals 6. That tells me k equals 6. Oh, so sometimes that the k, the plus c, the plus k will be whatever that that fixed value is. It's not fixed cost in this case. It's the fixed consumption, I guess. It's the consumption at a 0 disposable income. So then, and I'm going to cheat a little bit. I'm going to go over here, and I'm going to say, so C of y equals, and that's going to be 0.3y plus 0.8 radical y plus 6. Let me turn that sideways so you can see it. You notice what I did? I did make the y pretty. Instead of having y to the 1/2, I have radical y. Now, do you have to do that? No. Is it considered proper? Remember the rule. If I haven't mentioned it before, I'll mention it here. You always look at what information's given to find out the language you should use in your answer. If there's a radical in the question, then write it with a radical in the answer. If this had been written like this, with the exponent, then I would have left it in exponent form. Okay? So there's our answer. Woohoo! There's our consumption function given the marginal propensity to consume. Now, I know you're all not asking a question, which I'm going to answer anyway. This looks complicated. So what are the chances that we would have this and not this? And the answer is pretty good, actually, because finding an overall function for consumption can be very tricksy. But what you can do is you can measure the change. So I can say right now, national disposable income is 0. And then I could look in a little bit, look at another time in a day or a month or a week. I'm not sure how the economists measure this, but I could look and collect data and see that over multiple months or multiple years, as the national disposable income goes up and down, I can see how the propensity to consume goes up and down. I can model the change. Whenever you're modeling change, you've got a derivative. And then that helps us get the total. Woohoo! Isn't that great? Because people are really good at noticing change, or it's a hard thing to come up with the actual description of what's happening. But I could tell you what's changed. Okay, you ready? Dun dun dun! Okay, one other problem. Oh, pardon me. And this one I just thought was really cool. It's very simple. It's much simpler than the first one, but a lot of times when you get a problem where you're given nothing, it looks like you're given just a couple numbers and you're supposed to make things out of thin air. How in the world do you do this? Well, let's take a look. It says, if the national consumption is $9 billion when national disposable income is $0. So this is a different situation. Disposable income is still zero, but now we're describing a situation where people are spending even more. So that's interesting. And we could talk about why that might happen. But people are spending more. People are not saving. So, and we don't know anything about the situation. Is this a situation where it's, it's winter, so people are out buying more coats? Or is it a time when things look really good and so everyone's really excited and hopeful, and so they're spending more because people, when they're excited and hopeful, they're spending more because they're hoping that things will get better. They'll be able to pay off their bills. So there are a lot of things that could make consumption increase on the national level, and we could discuss that, but we're not in class. So we're just imagine that conversation, or come find me. Let's have that conversation. So I know, here, let me use some letters, not letters, some colors. The national consumption is 9 billion when national disposable income is 0. What does that mean? You're right. C of 0 equals 9. That whole sentence, or that whole phrase or clause, or I wish I had a linguist. I need a linguist to help me with that. But C of 0 is 9. Woohoo! Okay, now things are getting, well, I don't know if they're getting jiggy, but things are getting interesting. The marginal propensity to, and be very careful with your reading, because that's the marginal propensity to save. Okay, that's ds dy is 0.25. Oh, my hands and their choices about the numbers they're willing to write down. I don't even know. There we go. 0.25. Okay, find the consumption function. Now, in the previous problem, we had dc dy and the c of 0 equals 6, right? This time we don't have dc dy, we have ds dy, so we have to do an extra step. So I'll remind you that ds dy and dc dy are related in this equation. That basically they add up to, and I always think of it as 100%. One is 100%. 0.25, 25%. So if people are tending to save 25%, then they're consuming about what? 0.25 plus something is 1. So dc dy equals 0.75. Woohoo! Yay! Okay, so now next step. Now we know what dc dy is, and we know c of 0 equals 9. Well, this is, I know the last one, dc dy, the marginal propensity to consume, was kind of really all over the place. It was all sorts of interesting things going on. We've just got a much simpler one. It seems that the marginal propensity to consume is fixed at 75%. So to find the consumption function, and sometimes when you're not given enough information, it actually means that the problem is easier than you think. Because if you integrate 0.75, you just get 0.75y plus some k. Okay, c of 0 equals 0.75 times 0 plus k, which is 0 plus k, which equals 9. So that tells me k must equal 9, right? Oops, that went off the side. Didn't mean to. Sorry about that. So our whole c of y, it's actually, this is, even though we start off with less information, it turns out this is way easier than the previous problem that gave us tons of information. So just because it's kind of scary and thin doesn't mean that it's a hard problem. You just have to remember what everything stands for. So let's look again. National consumption is right there. I didn't underline this with pink. Let me underline this with pink. This is this one right there. Put a square around it. So we get these two clauses give us these two pieces of information. C of 0 equals 9. The marginal propensity to save is 0.25. And then from that, we get the marginal propensity to consume. And then we integrate. And then we get our function. And this is our consumption function, which we can then use as to talk to models that we set up. Woohoo! Okay, we made it. Godzilla, we made it. Godzilla's so proud of you. Godzilla knew you could do it. I knew you could do it too. You're awesome. Thank you for making it through all these applications. I know there's a lot of stuff going on. Hopefully some of it's interesting. Please don't hesitate to ask me questions. Definitely go geek out online, find out more. The book that we're using doesn't have a lot of information, so hopefully you're studying it in other classes. And if not, and if you're eager to know more, hit me up. I will find the information for you. I will geek out with you and we will investigate this. And if you end up loving economics, win-win for me. So otherwise, though, go hydrate, pat your brain, tell it did a great job, and I will see you next time. Math on and woohoo.